Morning. So I had bread and jam for breakfast today. Let's say brown bread, yeah. So brown bread, and it was square, pretty much square, where each side was the same. Maybe 8 centimeters. Yeah, it's a seven. Let's say 7 centimeters, and it was not exactly square because it was like this, right? So what we'll do is oversimplify it and find the surface area by considering this bit here as a semicircle and this bit here as a semicircle, and this rectangle here. So think 3 shapes and 4 parts, okay, where this is part 1, this is part 2, and 3 and 4. And we are going to find the areas and add them all up. So area of a square and rectangle, square, rectangle, semicircle. So how I think of area of a square would be, choose black is good, would be, think of a line that is 7 centimeters and you multiply it with 7 as if this line segment of 7 centimeters is moving this way and making up an area, a second dimension, 1 dimension, 2 dimension, a second dimension this way, and getting the area of 7 multiplied by 7 is going this way, yeah. So that's 49 centimeters square, 49 centimeters square. And then the rectangle is also the same idea. Let's just say this is 1 centimeter, this bit here, and goes 7 centimeters downward. That's 1 times 7, which is 7 centimeters square. And then 2 semicircles that make up a circle, and we have the area of the surface area of the one of the breads I had today morning for breakfast. So I like the circle idea, and 2 semicircles make a circle, and since the diameter is 1 centimeter, a line that passes through the center of the circle, diameter 1 centimeter. So half of that, half of 1 is 0.5 centimeters, and the area of a circle is pi r square, irrational number, pi, radius r. So pi times r square, and find this number. Talk about pi another day, and this number and this number, and we have the area of that particular shape. So let's focus on 0.5 square. So that's beautiful, yeah. Let me talk to you about why. So what 0.5 square is, let's say use blue. So 0.5 square is 0.5 times 0.5, which is half times half. So what we're doing with the half is multiplying a half to it. So this decreases, this is 1 by 4, half times half, and 0.25. The beautiful bit to notice is when a number between, let's just say positive numbers for now, between 0 and 1 is multiplied by itself, in this case twice, but how many ever times, when it's multiplied by itself, this is multiplied by itself, the number decreases, which is fantastic, yeah. It's a beautiful idea to sort of wrap your head around. So think of 5 square, which is 5 times 5, it increases. 5 square, 5 square 25, but 0.5 square times 0, no, let's just say 0.5, forget the square here, which is a number less than 0.5. So when I think of increase and decrease by multiplying with itself, I think of a graph, and let's use black, okay? You think of a graph, and say you're starting somewhere at 1, and this is the y-axis, x-axis. So any point in the graph you start here and you multiply with itself, it increases, this decreases. So the idea of sound, where when you hear numbers, is represented by frequency and wavelength. Okay, let's spend time with that. So wavelength, sound is longitudinal, but for oversimplification's sake, let me use a transverse curve. This whole bit is a wavelength, one wave, and the number of waves in 1 second that passes through a certain point. Say you start here and you say wow, and then the number of waves that pass through this, the number of wows is the frequency, yeah? So waves per second is frequency. My understanding is hertz, but light is a transverse wave. When you think of sound, you want to think longitudinal, which is how some density change, like what you're hearing now, is creating a difference in density in the space around you, the air, and there's compression, and there's expansion, compression, and expansion. So creating sort of a pattern that in some sense even smells different, yeah? Because if you notice, the recording that you are hearing is not conveying all the sound that I'm saying, because there are limitations of bandwidth and expression. So consider a band width which is, say, a certain length. Let's just say x, yeah? Let's have some fun with algebra, yeah? And we have information flowing at say 100 megabytes per second, yeah? 100 megabytes per second. So 1 megabyte is 1024 bytes. So the 1024 is actually a multiple of a power of 2. And let's just figure out how much. So you have 2 to the power 3 is 8, 2 to the power 5 is 32. So 2 to the power 8 is 240, 256. So 2 to the power times 2, that's 1000. No, it doesn't, huh? No, 512, 2 to the power 9 times 2. Fantastic. 2 to the power 10 is 1024, which is actually related to the idea of bits and bytes, yeah? So you want to think of a bit as either 0 or 1, which is the base 2 number system. Base 2 meaning only 2 numbers are possible, either this or this, yeah? Now a base 10 system like the 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0 have 10 numbers, 1, 2. So this is the base 10 system, the numbers that are used in everyday life. But this is the base 2 system where you have only 2 numbers, and this can be extended to say base 3, base 4, hexadecimal where you have 16 digits with the A, B, C, D, etc. But let's stick to say base 2, and let me introduce say even base 5. Yeah? So say base 5 would have 5 numbers, so 0, 1, 2, 3, 4. The number 5, 6, 7, etc. do not exist in a base 5 system. So you have 5 digits, 1, 2, 3, 4, 5, and all numbers, say the number 1042 in base 5 has a different value than in the base 10 system. Now let me just introduce that. No, we'll keep it for next class. Yeah, next freestyle math session. Look forward to it.